ladies and gentlemen. Hello and welcome back once again to the New Possible. My name is Eric Cavanaugh. I'll be your moderator for today's event. And folks, we're going to have a lot of fun talking about what is newly possible today thanks to something called artificial intelligence. This is going to be really, really cool stuff. We hope that you will share things with us socially. Use the hashtag of Inside Analysis and or Hot Storage. We'll be monitoring that during the webcast. And with that, let's dive right in. So the topic today is artificial intelligence. I saw a comment online just last night or over the weekend about augmented human intelligence as a better term than artificial intelligence. And we'll be hearing from several guests on our show today, including Ted Dunning of MapR, Nima Negaban of Kinetica, and Marty Falero from Wasabi. And Ted has a couple of really good ideas about ways to call these technologies, new names to use, monikers that may be more useful. But artificial intelligence is something that's been around a long time. And because of that, it carries a lot of legacy, a lot of connotation with it. And, you know, it may have been kind of burned out in terms of what people think about it, at least some people. But the fact is AI is now a freaking juggernaut. AI is fundamentally changing how business is done, and it's all over the place. You can find it in every industry. You can find it in just about every business process. A lot of it is up in the cloud. There are some reasons for that, just some practical reasons for where this stuff can be leveraged, what it can do. Of course, Apple has AI in Siri. We've got Alexa with Amazon is an artificial intelligence engine that is recommending things and doing things and taking decisions. We're at the very early stages of all this, I have to think. I mean, personally, I think that Siri is not very effective. I'm not a big fan of Siri, at least not yet. Maybe I will be sometime soon. But it is absolutely transforming business, and so we really need to pay attention to this stuff. Now, I have a theory that mostly AI and machine learning algorithms do two things: fine-tuning decision points and segmentation. There's an example of a k-means algorithm I'll be showing in a second. That's one of my favorites. And then there's deep learning, which is another whole ball of wax. Deep learning is really interesting stuff for exploratory research, for stochastic reasons, for example. There are lots of benefits for life sciences. I think that healthcare as an industry stands to benefit tremendously from machine learning simply because we can now run some of these algorithms at scale, covering tens of thousands of cases to understand, is this a form of cancer? Is this a form of MS? Is this a possible cure for some of these diseases? Machine learning is going to be incredibly valuable for healthcare in general, for diagnosis, for prognosis, for treatment plans, for medical care, for all kinds of pharmaceuticals, for natural healing, all kinds of possibilities coming down the pike. Of course, AI is good for self-driving cars. You need a lot of training data, though. We'll talk about that in a second. But it's good for understanding patterns at scale is the general point I'm going to make here. So 4 types of machine learning. We'll kind of dig into these a little bit more with our experts. Lots of different algorithms out there, and they all do different things. I'm a big fan of the k-means one, maybe because I understand how it works. But there are lots of different algorithms that are used in very different environments and for different things. So, again, we'll be hearing from some of our guests about how all that stuff works. And one of the most common that you'll see out there in the real world are these CAPTCHAs. I don't know if you're as annoyed as I am about these things. They do drive me crazy, but the general idea is they're trying to thwart the bots. They're trying to thwart hackers. They're trying to thwart all kinds of bad actors out there. And this is something where machine learning is pretty useful because if you, for example, you get the set of images that says click on all the images that have a picture of a car in them. Well, there's some machine learning behind all that which has enabled it to do its job. So it really is everywhere. It really is changing everything. But what's the key? You need a lot of training data. So some of the major AI engines that you've heard about, I won't name any names, can take 3 to 6 months to train, which means you implement them, you pay a bunch of money typically unless you use the open source stuff, and you got to wait 3 to 6 months before you really get any value at all. And then as you train these things, the data has to be pretty good. It doesn't have to be perfect by any means, but if you train an algorithm on bad data, you might wind up with some things that you didn't really want. And then, of course, another topic we talk about is regulation and compliance. So we've got this whole concept these days of the GDPR, the General Data Protection Regulation coming out of the EU. And one of the tricky stipulations with the GDPR is that if a EU citizen says they want their data taken out of your systems, the so-called right to be forgotten, number one, you have to do that. Number two, you have to retrain any algorithms that were trained on their data. Well, to be blunt, I think that's a bit unrealistic. I think that it's not really going to happen very often. But if you run a big company and you have EU citizen data in your databases, you should know about that. There's no doubt about it. So with that, I think I'm going to hand it off to our expert presenter of the day. Let me put his slides forward. And Ted Dunning, you know a lot more about this stuff than I do. Share with our audience your perspective on machine learning and what it means for business and what's cool about it. Take it away.
Yeah, absolutely. And I work here at MapR. But what I want to talk about today is frankly the bullshit part of machine learning. You just mentioned that the hardest part of the machine learning part itself is the training, but frankly the hardest problem of getting value out of the system is not the machine learning. And part of it is that we want to work in clouds. We want to also work on systems in our own data centers because each of them has an optimal load. We want to be able to move in and out of clouds easily. And we want to build systems. This is a typical diagram for the way somebody might build a system. A website might handle uploads. The upload might register things. Image extractors and transporters would run. People would write these as processing blocks separated by arrows. In the past, though, those arrows each had their own little snowflake nature and had to be individually coded. In a modern sense, this small piece here would instead have those arrows become message passing systems that are stored in a data platform. So that allows us to have containers. This is another very popular technical system that run these applications, these square processing blocks, and put the data into the data platform. But let's talk about how this happens in machine learning. The big idea is that streams are good for connecting components of very large computing systems, and that's what we have. But we can also then build these components so they can be independently deployed. That independence allows these teams to work relatively independently, and therefore you don't wind up with great big communities which always have somebody vetoing progress. If we can decrease the size of those committees, things get better. But adding machine learning is adding a new constituency to these small teams, a data constituency. So we don't have DevOps anymore, we have data ops. Training, it's a machine learning technique to build what's called a model. A model is just a program that we can then deploy, apply more data to, and fabulous things happen, right? That's the view of things. But it's not like that. Not like that at all, really. 90% of the effort actually goes into the logistics. Now, that's the way we spell it. We pronounce it with a word starting with B and continuing with S. The problems are, one, that training data is hard to get. It's hard to get partly because we have to get it as it was, and knowing what we knew and when we knew it is hard. It's also hard because it isn't just one model. We're going to have dozens for any given purpose, and then we're going to have hundreds of purposes. Pretty soon we're going to have thousands, and we need to be able to manage them, move to new ones, move back to old ones, and that becomes difficult to manage. And to make it worse, nobody picks one machine learning framework. Each one has a particular lifetime, a particular specialty, but there will be another one next month. And somebody is going to have to try it to see if it does better. Now, that's going to mean that our ops people aren't going to get it relative to the data and modeling. The data scientists, the people who are building these models, are not going to get it because their attention is focused on building models. They're not going to get it relative to service level agreements that you have and guarantees that you're making about it delivering results. So you have to have some system that lets people separate their concerns. Ultimately, we want a request and a response and the model to make a decision. If we have many models, we need to give the same request to all these models. Streams are great for that. They let us do that. But then we have multiple answers. We have to figure that out as well. So often what I'm advocating lately is a system called a rendezvous server. It lets all of the models see identical inputs. All of the models run in production. All of them send their results to a score thing. And then the rendezvous server on the right there rendezvous the original request with all of these results and picks one, anoints one to be the master, the one that gives the response, gets the response that you're going to return. Now, alternatives could be the low risk, it's going to get an answer, but it may not be as accurate. That's a great fallback that the rendezvous server could pick if the primary model is not responding in time. That sort of thing extends those original points and lets us decide which scores to use, which ones to ignore, and that lets us move to new models easily just by changing what we ignore. We can eject real-world external data very easily. We can build systems that record all the data we've seen. That makes the training data problem easier. We can even have other models like a canary, which is just a very stable model that we can use to compare other models to. We can even compare the canary's output to the previous canary output to see when the world changes. And so the idea here is that we can build a system that lets us manage this complexity, lets us separate the concerns of data people and operations people. And of course, we do it in a streaming style. The bartender says, you really ought to have it on tap. So that's the architecture for a modern day machine learning system. It may be a little bit techy, but the basic ideas here are really quite simple. Let's do it all the possible ways in the first instance, and we just pick the one that seems best in the moment. And we can even isolate development so that the people who are doing development get a firewalled system. We can build out metrics, and we can see changes that happen. So this is an exciting development because it makes a lot of the logistics, aka bullshit, parts of the problem much easier to manage. Now, here at MapR, of course, we build a platform that tries to make that happen. And it has many of the primitives needed to build that sort of thing. Back to you, Eric.
One of our attendees was joking, can he go faster? I can keep up.
So sorry about that. Part of this speed here is fitting into 20 minutes, and part of it is they're going to get the slides later.
That's right.
And hopefully they'll be able to go, oh, yeah, right, that's what he said at that point. So I actually put in a few slides that say more than I said today, just for that purpose.
Well, this rendezvous
and of course
concept, yeah, just very quickly, this rendezvous concept, I think it's been the missing link, right? Because one of the big challenges with machine learning, again, is just getting new models deployed, being able to manage those models effectively. And to me, you kind of thought outside the box there and came up with, I guess, a balancing agent, but it's almost more like a marshalling agent. Is that a good way to put it?
Yeah, you could call it that. And I see it a couple different ways. I don't want to claim too much originality here, but a lot of this comes from the intuitions that our customers have had and friends of mine who developed in places I've worked before. This is more a synthesis. But yeah, the idea is to separate concerns. Some folks are going to be worried about the reliability, and they need to focus on that. Other people are going to worry about the accuracy, and they need to focus on that. And you can't have everybody worry about everything all the time.
That's a great quote. You can't have everybody worry about everything all the time. And, you know, there's a question that came across the transom here about biases. We're hearing a lot about biases in algorithms. I'll give you just a bit of context for myself. I think some of that stuff is a red herring, but I do believe that there is some value in just really taking a very hard look and an objective look at the results of these algorithms. What do they generate? What are the decisions that they generate? Of course, they're going to reflect the training data, right? That's one key you have to keep in mind. But what do you think about this whole concept of biases in algorithms and how to manage that?
Well, there's unfortunately a technical term called bias, and that distracts the issue a little bit, so that gets data scientists off on the topic of bias and variance, which is probably not what the question asker is asking about. I think they're asking about classic bias, where a decision may be canted a certain way, which is not necessarily the way we want to cant it. It might be against certain groups in society, or making a knee-jerk decision where we want to consider decision or anything. And I think the key thing there is not going to be a technical answer. There will be technical tools that we can use to help avoid this. But there's a human answer, and that is humility. It's going to be very easy always in this kind of system to be very proud of the model we just built, and to trust it, and to imagine it's the most wondrous thing ever. But then we have to take a self-critical look, and examine it, test it in very, very simple ways for classic cases where people's unconscious bias pops up. Try name changes, try simple permutations of input, and see if the decisions change inappropriately.
Mm-hmm. And, you know, I had an idea last night, in fact, today it kind of crystallized as I was putting some slides together for this, and I forgot to get to this slide. But I'd be curious to hear your thoughts on this. I was thinking about deep learning models in particular, and there are just so many component parts that go into deep learning models, right? There are inputs, there are outputs. You can move them around and put them in different arrays, for example. They can be very complex, or they can be fairly simple. And I thought to myself, in many ways, these deep learning models are kind of similar to circuit boards, where you've got, just to oversimplify things, resistors, transistors, and capacitors, but it's combinations of those things which can do all kinds of interesting stuff. Do you think that's an interesting analogy of deep learning models, or even predictive models, with circuit boards and their component parts?
I think it might well be. It might not be a very widely held analogy, because it depends on multiple generations of technology. Back in the Dark Ages, before we had even dirt, we had just rocks. Young people may not get that that's a joke, but it is. It's just not necessarily a really great one. But back in the Dark Ages, electronics were built out of discrete components, and you would have a capacitor connected to a vacuum tube or printed circuit board, and they're pretty low-level functions. Stores a little tiny bit of electrical charge, or builds a magnetic field or something. And later people started putting multiple functions together in one thing, and components, even very complex components, ultimately entire computers, could be reused as building blocks. And that is, in fact, kind of one of the side effects of the way deep learning works, and it allows us to do something called transfer learning, where we build a system for one purpose, and then we use some aspects of what we learn about the world and the environment from that first task to help us build a second task much more quickly. And that can mean that we actually wind up training on thousands of times less data for the second task. And this is, if you have somebody that you have taught to be a carpenter, and you say, I need you to connect these two pieces of wood together, or I want to show you how I want them connected, that carpenter can learn that task extraordinarily fast, because they are expert in the idea of joining pieces of wood together. And so even though they have not joined those two pieces of wood together in exactly the way you want them to be done, they can learn it fast. You probably even just describe it to them without showing them. That's called one-shot learning, where you learn in a single example. And that is one of the side effects that we're seeing in deep learning, which is very, very exciting, because people can build simple systems. A friend of mine maintains a Twitter feed called Tensor Chicken, and it started when he was monitoring his chicken house for blue jays coming in and pecking the eggs, and he was able to reuse a Google Vision model to do that.
Wow.
And then he had it tweeting to the web under the name Tensor Chicken. and I think he has it looking at hummingbirds now, yeah, and identifying them.
Wow. That is cool stuff. Well, hey, stick around if you can. If not, I understand, but we'd love to keep you around for the roundtable, and I'm going to hand it off to Nima Negabon from Connecticut, who's going to share with us his thoughts on machine learning. That was a fantastic presentation, Ted. It's always fun to have you on these shows. Nima, if you would, use the quick start at the top of the screen there. Yeah. Take it away. And Nima and Ted were both just on our radio show. For those of you who missed it, we'll be posting the podcast later at InsideAnalysis.com, all about new possibilities with artificial intelligence. And with that, Nima, take it away.
Yeah, so, what I'm trying to focus on is actually how, AI work is getting done almost from an organizational perspective in enterprise, and how we can, do that better, and that's one of the major kind of focuses of Connecticut. And really what you see is kind of these silos of functionality and functional units, right? And so, you want the separation of concerns, right? But you also need people working together, right? So right now it's very common, you have an executive sponsor who, potentially is trying to make a certain operation more efficient. For example, for oil and gas, they want to predict, rig failure better. And so that they pass it off to a team of data scientists. And the data scientists will get a very limited amount of time with an SME group to kind of, try to understand, the real world thing that they're trying to predict. And then they go back, to the lab, and they have kind of limited access to operational data, but they have, what was supplied to them. And so that they work that, they get to a certain accuracy level that they think they're happy with, and they pass it off to IT. And right now, a lot of, new users of enterprise ML are in this kind of very common workflow model. And so, I mentioned some of the problems, but, you've got basically an IT department that's kind of nervous about trying to operationally support this, and also making sure that the data that is being fed in and trained against is kept up to date and has the kind of necessary lineage, right? You've got your data scientists who are just cut between, about 500 different stakeholders, and in the middle of it all, trying to make sure everyone's kept happy, doing stuff that they're not necessarily good at with, systems engineering tasks. And, at the same time, they need to be able to focus on their algorithms and make sure that they deliver the best, model ensemble. And then you have your executive sponsorship, who is trying to be forward-thinking, but is also worried about, potentially, downside risk to, putting a model, an ML deployment, at the center of his or her operation, and making sure that they understand, how to explain it to other stakeholders within the organization, and, making sure that they understand how to enable the rest, of this workflow to properly do this. And so where we come in is, really as a kind of parallel system to kind of your systems of record, right? Connecticut is coming in as something that is, ready and positioned for, very, advanced data analytics and BI, right, as well as kind of deployment and operational footing of ML. So, we're kind of branding this as like a system of intelligence, where we're really taking an ML-first approach to making a data warehouse, right, and putting those needs that, are derived, as far as, features that are needed in the products, putting those first, and that includes collaboration. So, we're calling this the virtuous collaboration cycle, where, you've got everyone really working through a common platform that can, kind of distill what's going on in the life cycle in a way that makes sense for that stakeholder. For subject matter experts, it allows them to quickly come in, slice and dice data, and kind of share those features with the data science team. The executive sponsor can get a kind of a dashboard view of where work is and where the model is deployed. And then you've got, the IT group, who has everything in a single converged platform, has data coherency, and has a very easy to use deployment system that interops with things like Kubernetes, and has the necessary hardware to get the best performance. So that kind of is, one of the major things that we're trying to address with Connecticut. And then the next is building out the kind of instrumentation necessary in the framework that we're building out, so that data science teams can more easily kind of hook into our framework and leverage our framework so that we can more appropriately meet the demands that are coming online when we're talking about operational ML. And so, one of the big ones is trust. And we've been talking about that on the show before. How do I trust this decision? How do I trust this model? And so, one of the theoretical frameworks that we think is most interesting is LIME, Local Interpretable Model Agnostic Explanations, where we're actually building out an automated way of leveraging LIME and helping data scientists really evaluate what is driving the decisions being made by a model. So it can be used in a number of kind of classic model algorithms, but this one is just for classic image classifications because it's pretty easy to understand. You bring your image in and you break it down into a set of features, right? And then essentially, what LIME is talking about is doing, a linear regression where you're doing locally weighted perturbations or modifications, and figuring out how that impacts your overall score, so that you can come away with your highest weighted features. So, this is a common example of something that makes sense not just for image classification, but for a wide variety of models. And so, this is a kind of theoretical slide, but it's something that we're building in an operational footing for Kinetic and giving that out as kind of like an SDK to data scientists. And the final part is around transparency and tuning. And I mentioned the Discover Weekly problem with Spotify, but as you talk about really becoming a full lifecycle operational system for ML and being able to deploy models, right? You want to be able to provide the necessary instrumentation to your developers, whether it's in your data science team or in your app experience team or your app team, so that you can have the more rich and powerful relationship with your users, so that they don't feel boxed out. They don't feel like your ML footing is a black box, right? They feel like they have control. They feel like they understand, and that they're getting the best experience. So, I mean, the Discover Weekly problem is actually something that kind of perfectly depicts this issue where, you've got a great model, actually. Like, people love it, right? If you go, there's actually like a 6-7 page long forum, posting just about this issue. And people are really despondent because they loved their Discover Weekly, and then all of a sudden they did something and now it's ruined, right? So, the data science team that initially made this system, they did a great job, right? And now, because they didn't kind of think about the entire life cycle, or maybe they didn't have the instrumentation from an infrastructure standpoint, they have a big frustrated user base that, is thinking about switching to other platforms because they can't fix their discovery function, right? And so, thinking through this entire life cycle and trying to drive on collaboration, trying to drive on transparency and verification and trust is really what we're focusing on. And, we're coming from the lens of, having a premier kind of hardware platform in the GPU to both help data exploration, but also drive, these ML workflows using libraries and frameworks that, everyone's kind of used to, and having complete flexibility. So, yeah, this slide is kind of just, reiterating where we stand, in that kind of ecosystem. But, yeah, that's pretty much all I had.
Yeah, I love the systems of intelligence concept, and I'd like to ask you to comment on Ted Dunning's idea of this rendezvous server. You bring up a really interesting point about a model or for an individual person and their music preferences, their discovery getting kind of ruined, right? One bad apple kind of spoils the bunch, right? I see what Ted is talking about as a way out of that, but what do you think?
No, I mean, I think the tool chain and standardization around kind of ML and rendezvous is an interesting example. Is definitely maturing and allowing for, the necessary instrumentation to solve the problems like we're talking about. I think there's going to be, a couple kind of, horses in the race, and, we're interested in being as, kind of open as possible and integrating, with these different products.
Well, I think you talk about this too, and Ted does, and I do as well. Transparency is going to be so important going forward. Just understanding what happened, what's going on under the hood there, right? I mean, and one of the interesting challenges is going to be revolving around rules and regulations like GDPR, right, where they say, well, how do you know, how did that decision come about? Like, well, the AI engine came up with it. Like, what do you want from me? That's going to be hard to unwind, right?
Oh, absolutely, especially as you layer, models on top of models, and, you've got more and more advanced kind of data transformation to get to your feature layer. I mean, most, kind of modern ML pipelines are already very, very, kind of multifaceted and layered. And so we got to have, systems in place that, ease that unwinding process and ease that audit process, because, things like GDPR are going to become very real. And, as ML becomes more and more central, it's going to become, it's going to be making more and more important decisions in people's lives. And so you're going to have to, go from soup to nuts, from the decision all the way back to the data that actually, made the features, that trained the model, that made the decision, right? So audit and its kind of theoretical and infrastructure challenges are a very real thing.
Yeah, no doubt about it. And as I think about, again, as we discussed on the radio show, the disparity between the cutting edge these days and the sort of laggard methods and protocols and technologies, the legacy systems that are out there, it seems to me that disparity is growing by the day. And it's almost as if we've got two high-speed trains that are moving at a slightly different trajectory. You're not going to be able to stand on both of those trains for very long. You're going to have to pick, either go down the old road or go down the new road, right?
Yeah, absolutely. I mean, I think kind of, as we go enterprise to enterprise, we're seeing, kind of how, ML forward their positioning is, and how much, they're really kind of jumping in and adopting the new kind of tool chain around ML and not trying to kind of, bridge those two worlds or kind of drag, the old world along with it.
No, that's a really good point. Well, let's go ahead and bring in our final guest here. We've got Marty Falero dialing in from Wasabi. Of course, they are the underwriter for our whole series here. And with that, I'm going to hand the keys over to Marty to talk about one of the important parts of this whole picture here, which is storing the data somewhere, the training data. You need a lot of data to train these models. And we're starting to see all around all this commentary in both the consumer world and the business world about the storage costs going down, right? We're starting to hear about some really exciting things. The new iPhone says that you'll never run out of storage. These are all straws in the wind that cloud storage costs are going down, but the key is it still has to be fast, right? If you're going to use it for enterprise applications, it can't be on a tape somewhere stored in a mountain place someplace, right? You've got to be able to get access to this stuff. So with that, I'm going to hand it over to Marty Falero of Wasabi. Take it away.
Thanks, Eric. That's a great point and a good kickoff for the few slides I wanted to share. Really, artificial intelligence, I think we've heard from the radio show and now with the webinar, is changing every aspect of how we interact with and use technology. It really represents a huge boost to the global economy as some of these new technologies become new products that we use every day, and we saw some of those on display at during the Super Bowl ads last night, although my personal favorite was the spoof on all the Super Bowl ads by Tide. But as you look through one industry lens, and I'll just pick media and entertainment as a particular industry where this is having a huge impact, we're halfway through a 10-year period where the cost of creating and managing video is plummeting while the adoption is exploding. So just 5 years ago, managing video was really a labor-intensive process, and it was all done at the studio. And roll the clock back to just last year, and with the emergence of cheap cloud storage and artificial intelligence to manage your media, things change very rapidly. And 5 years from now, according to the predictions, there's going to be billions of mobile devices connected to very high-speed 5G, 6G networks, whatever the next frontier is, with artificial intelligence-enabled cloud compute and storage that'll drive the cost down even further, even though the amount of video going to be made available is exploding, and the number of teams in the media and entertainment industry is growing tenfold from 5 years ago to 5 years out. So let's take a little closer look, and this is something that we've seen in terms of the opportunity to store all of this data. Video is really dominating infrastructure as a service growth. And the stats that we've seen are that really about 25% of all the storage being consumed right now is being used for video, and about 75% of the internet bandwidth is being consumed by video. And over $1 billion is being spent just in post-production software and cloud services. So there's a huge dynamic going on just in this particular market segment. And one of our partners is a company called Axle AI, and what they've built is a powerful search engine that delivers deep learning technology to a simple manual task that has been the bane of many a content owner's existence, and that is tagging scenes and objects in movies and broadcasts. And this powerful tool now automatically tags the scenes in movies and broadcasts versus having production assistants watch all of these scenes and insert manual tags. And the media can be stored in the cloud where this artificial intelligence technology from IBM Watson, Google, Microsoft can provide the tagging automatically. And this was all previously done manually, and it's a tremendous tool as the amount of media continues to explode in that particular media asset management sector of the industry. So why is Wasabi being used to store AI data? Well, a little bit about Wasabi. The company launched in May of 2017. We're headquartered in Boston, and the company was founded by the original founders of Carbonite. And what we're doing is we're delivering cloud object storage as a service. And it's, you know, the industry examples, the big fish that's out there with the market share right now that's been around for 11 or 12 years is Amazon. But they're not alone. Microsoft and Google are also there. But since we launched this service only last May, we've already got over 1 billion objects being stored by more than 3,000 accounts. So I want to tell you a little bit about what we think we're onto, and we're dubbing what we do as hot storage at cold storage prices. So when you think about Wasabi, there's really this opportunity now to build a brand new file system, and that's what we've done. We're just focused on object storage. We developed a file system that leverages the performance improvements that have happened in both the software and the hardware over the last few years, and it gives us a tremendous performance advantage over Amazon, the market leader. And we've decided to also flatten pricing and introduce this idea of commoditized storage pricing while still protecting the data, and I'll get into a few details. On the pricing side, we've launched a very flat storage pricing, and it's literally 80% lower than the industry standard that is Amazon. And the reason we did that is that we don't understand why there are so many levels of storage and different tiers and different elements being priced and being charged to customers. And candidly, cloud storage has not been used by 2/3 of the market because pricing is about the same as having storage on premise. So we've really focused on combining commodity pricing with great new technology from a file system perspective. And the performance that we've delivered is phenomenal. When you think about artificial intelligence, we'll talk a little bit about why performance matters, but I think everybody can already appreciate from listening to the other presenters how much data is actually being consumed when machine learning is happening. And so we've introduced a brand new file system, and when we tested it against Amazon, taking the exact same amount of data and storing it in Wasabi versus Amazon, we were able to achieve 6 times the performance, which becomes a big deal the more data that you're putting into the file. On the protection side, we've heard about GDPR as a good example of the demand for protection, and we've built not only exabyte scale into Wasabi, but we've also built system durability that's equal to the larger players in the market. So 11.9's system durability means that we will not lose your data, and the way we interact between the data and the file system is such that we're able to offer tremendous protection. The data is encrypted at rest and integrity checked every 90 days. And we've introduced a unique feature called immutability. So you can mark a bucket of data as immutable for a period of time. And that means that the data cannot be accidentally deleted or modified in any way during that period. So immutability becomes a really important feature, not only in media and entertainment, but in terms of having the data be protected that's driving machine learning. And then we leverage all of the Tier 4 data centers that are popping up around the country in terms of where we have the Wasabi cloud located. There's a lot of use cases out there, Eric, that we're seeing. I talked a little bit about media and entertainment. When you think about AI, it really goes across all aspects of both consumer and business use. And we're working with customers in healthcare and life sciences, as well as scientific research. We have customers in the government and education sector. IoT data is coming in droves and needs to be stored, and also software companies. So when you think about the idea that cloud storage matters when it comes to artificial intelligence, we talked to a few analysts getting ready for this event, and we really were able to understand some of the big industry trends that are driving the need for really fast available cloud storage at commodity pricing. And really, when you look at cloud compute, which is used for AI tasks, it's been growing. The speed of the cloud compute and the performance has been growing much faster than the speed of the storage. And slow storage really does slow down the machine learning and training. And the performance could leave many key insights locked in the data store. And the last point on this is just Tesla alone is tracking 1.3 billion miles of driving data, and the idea that you would have scalable cloud storage is really critical to being able to handle driverless vehicles and some of the other work that's going on just by one company in one industry segment. So that's really my sort of quick tour on what we're up to on our side, Eric.
Yeah, no, this is good stuff. And, as I think about the machine learning, and I'll bring in Ted and Nima, if I could, just to kind of comment on this, that story you were telling, Marty, about video and being able to use machine learning to trawl through hundreds of hours of video to find useful bits of information. Well, we did a show last year about law enforcement and how useful that is for law enforcement. You figure casinos have been doing this facial recognition stuff for a while now. I think they're really on the cutting edge for the obvious reason that they have a lot to gain from knowing who's walking into the casino, whether it be someone who has ripped them off in the past or a whale walking in, a guy that spends a whole lot of money in the casinos. But you start thinking about trying to be able to problem solve in situations where terrible things happen, like the marathon in Boston where the bomb went off. Being able to use machine learning combined with all that video footage, suddenly that becomes a very compelling storyline. I guess, Ted Dunning, I'll throw it out over to you as a machine learning expert. There's a lot of interesting stuff that's going to be possible now thanks to machine learning, especially on video and on just tracking who is where and what's happening out there in the real world. What are your thoughts on all that, Ted? Is he still out there? Maybe we lost him. I'll throw it over to Nima, maybe.
Sorry about that.
Oh, there you are.
Mute button issue.
There you go. Go
mute
ahead.
Button disease. I think there is a lot to be done with that video, but I think we have to be pretty cautious about integrating that sort of thing.
Sure.
They've been touting in China that they have a surveillance system that can track people and find out where they were and so on. And I don't think that's the sort of system that we actually do want in a lot of places. So we certainly can look at a lot of things, and we can also anonymize a lot of that. Retailers may want to see which products people pick up. Video is a great way to figure that out just by looking to see who picks it up. But it doesn't mean necessarily you want to track people through the store and invade their privacy.
That's right. No, this is one of the real major issues that we have to face here, and I think we do have a sort of moving target right now as regards all that, back to the point that Tom Kalopoulos was making on our radio show before this webcast, that different generations have different beliefs around these things. Younger people, I heard, and I guess maybe Nima will bring you in on this, I heard, or I was reading online, someone talking about the dark web, and I realized that a millennial was referring to email as the dark web as opposed to posting something on Facebook. I think that's a bit strong. I think I do see the use case, the need to have personal email that goes to one person and not to everybody in the world. So I think that's a bit Pollyannish. But what do you think about being able to cater these kinds of technologies to groups of people who are open to it as opposed to groups of people who are not open to it? Nima?
Yeah, I mean, it's interesting. I mean, I think that the actual technology is widely pervasive. I mean, like OpenCV is an open source library that's, you know, the basic tutorials on how to do exactly this, you know, entity detection, and, you know, you can very quickly stitch together something that's monitoring entities that get in front of a camera, right? So I think there's an opportunity for a lot of creativity in this space where, you know, potentially, you know, things like ad networks that are merging your online persona with your physical persona, and you know, you being okay with that because maybe you get some sort of benefit, right? You know, there's no easy answer. I mean, I think we're going to have to figure out, you know, where we draw the line and how we walk that line, and what's in it for the consumer, or, you know, kind of what is the relationship between, you know, the consumer and all of this kind of data collection. And that is, I mean, ML can, like, what we're actually talking about is data collection that's driven by ML, right? So ML is going to exponentially increase data collection just by, you know, the mere function of its kind of, automated classification capability, or, you know, its ability to say that this is, you know, X entity going, you know, in this position on the Earth at this time, right? So I think it's going to go a lot of ways. I don't really necessarily know, you know, that there's one answer to this question. I think, you know, there's going to be a set of solutions that come out that are going to be really creative and are going to probably create new businesses, and consumers are going to have a relationship that they understand and like with it. And then there's going to be malicious users and you know, other entities that are leveraging it in different ways. But I mean, you know, it's happening now, I'm sure, because, you know, that it's not, you know, not very, the barrier to entry on the technology side is basically zero. So it's a good end, that thing.
Yeah, that's a really, really good point. And Ted, I wanted to push this slide out to have you take another minute to kind of walk through. I love this concept of the canary in the coal mine, of course, is the reference. Back in the day, miners used to bring a canary down because the idea was if that canary drops dead, you better get out of the coal mine. And I think this is a great concept to use in the application of machine learning. Can you kind of talk about the concept of a canary in terms of machine learning algorithms and how that stuff works?
Yeah. Well, one thing that I didn't talk much about when I was zipping through it, as your audience said, high speed, is that a machine learning model that is making a useful decision for you actually is doing much more than that. It also has learned the cognitive structure of the space needed to make that decision. Otherwise, it couldn't make that decision. But the fact that it understands that cognitive space means that you can actually use the model as a diagnostic as well as a decision maker. And you do that by looking at the score distribution, the distribution of outputs from that model. And that distribution is going to be a very sensitive indicator of the structure of the world in the context of that business-like decision. And that means that if the world changes in an important way relative to that decision, relative to your business needs, that score distribution is going to change. And that is a really, really exciting thing. That means you can run the same model. It's not even a model that you necessarily are looking at the outputs for making decisions. You may have better and newer ones. But the fact that you know that score distribution, that's the little first icon there with a graph in it, lets you understand, has the world changed?
Yeah, this is fascinating
and then, of
stuff.
Course,
yeah, go ahead.
No, go ahead.
Yeah, I was just going to say that I was talking with one of the senior-most people at SAP a few months ago, and we were talking about machine learning algorithms, and he runs the supply chain business, and I was suggesting that you really do still need humans in the mix to monitor these things and to push the green light when necessary. You can have alerts, obviously, and be somewhat dynamic. And he shook his head. This is Hans Talbauer, I think is his name, from SAP, and he told me that some of the biggest brands in the world, of course, SAP has some really big customers, are letting the machine learning algorithms run their digital supply chain. I mean, just actually run the whole show, which is just downright fascinating. And it does make sense when you consider just how complex those environments get, the number of different parts that are necessary to manufacture this particular widget or that particular widget. You can't have a human being wrap their head around all those dimensions and all those interdependencies. So we really are moving in the direction where we'll have machine learning much more dynamically and automatically managing really mission-critical business processes, right, Ted?
Absolutely. And, well, they already are, but much more so in the future. There'll be an awful lot of that happening. And hopefully, mostly for the good. But it will be up to all of us to make that true. It may happen by accident.
That's right. And, Nima, just some closing comments from you. Of course, as I mentioned, you guys kind of came out of the military world where you were being used to protect lives that were in danger. So I think you guys realize we are danger close to some pretty strange and interesting times, right? And I would imagine you guys have to keep that in the back of your mind as you talk to clients and you help them leverage these technologies to do cool things, right? There are always going to be these ethical questions that we have to keep front and center in our minds, right?
Yeah, I mean, I don't think they go away. I mean, all we can do is provide kind of the better tools and infrastructure to kind of help understand decisions that get made and models that get deployed. I think, you know, as models get more complex and they are able to, you know, take on, you know, higher and higher dimensionalities that, you know, go on to infinity, you know, that's always going to be a challenge of, you know, why is this making this decision? When it no longer becomes a small amount of features or, you know, a couple 100,000 features, but goes on to, you know, billions of features that it's considering, you know, the task of explaining it is going to be as challenging as the building of it in the first place.
Yeah, that's exactly right. And just, you know, the big challenge here, I'll just throw a last comment over to you, maybe Nima just comment on it, and Ted, if you want to, or Marty. We're in a very strange time now where certainly through compliance you're going to have regulatory agencies wanting to peek under the hood to better understand how these engines are working, but at the same time, that's proprietary stuff. How you piece all these component parts together, that's your magic. That's your proprietary magic. So it's going to be a very odd balancing act, I have to think, going forward. And my guess, and maybe Nima, I'll turn it over to you first here, is that as an organization, especially if you're a large organization using some of these technologies, you're going to want to have something that you can show. You're going to want to tip your hand a little bit without tipping it all the way down, right?
Yeah, I mean, you know, and we're actually seeing it already in the autonomous vehicle space where, you know, auto manufacturers wanting to do autonomous vehicle testing are having to at least give out deterministic reports of what they're doing, the activity that they're doing. And, you know, you can very much well imagine that, you know, there's going to be a follow-on requirement to at least give some, you know, collapsible set of a decision or decision explanations where, you know, maybe you're taking in billions of features and you know, making prediction across that, but what we'll actually do is try to create some sort of collapsing framework where you can, you know, make it into a system that is easier to kind of, or like a framework, really, like a reporting framework that allows us to kind of convey the decision-making process of the model in a way that is at least kind of economically sustainable, because, you know, all that's going to take engineering time, and you know, it gets into a weird space of, okay, well, this government regulatory entity is telling me how to spend my engineering dollars. So it gets there's a lot of gray areas to be figured out.
Well, you know, the autonomous cars are a good segue for some closing comments from Ted on this. I think we're going to start seeing more and more a movement toward not just open source code that gets shared, but open source data and insights, especially around things like security, but around issues like cars and driving cars. What are the anomalies that you've discovered? You know, one of my good buddies, Mark Madsen, always talks about how if you build a new database, like a new analytic database or some new interesting, very powerful database, it literally takes years for you to encounter the edge cases that are going to crash your system. It takes years to come across them. And I think we're going to start seeing more sharing of information across industries. So let's take autonomous cars as the example, around accidents. What were the conditions that came together which caused that car to freak out and crash or do something bad? And I think that's a good thing. I think we're going to see the spirit of the open source software movement kind of infiltrate and infect the data movement, and we'll start seeing more sharing of really important data like security data, like safety data for cars. But Ted, what do you think?
Well, I think that regarding explanations, regarding transparency, I think we can draw a lot of lessons from the last time that we deployed intelligence agents to drive our cars and run our businesses and such like that. That was when we had humans do that.
Right.
We don't demand to look at all their neurons. We ask them to explain what they did, or we watch what they did, or we watch what they do on average, and then we make decisions based on performance. Because we can't really inspect knowledgeably the context and the contents of systems that complex. As AI systems become that complex, we will have the same problem. And we solved it once, we probably can solve that again in very similar ways.
Mm-hmm. Wow, this is great stuff. And maybe, Marty, I'll throw it over to you just for some commentary. You know, I think that you guys provide an enabling technology that can let our other speakers on the call and their companies do some really, really cool stuff. And I love David Friend's concept that he often talks about, that cloud storage is going to become like a utility, like the power in your electrical unit in your house. You don't have to get 10 different kinds of plugs. There are basically two, one for your usual electronics, one for your heavy-duty electronics, and that's it. And I like that concept, and I hope that we see some standardization around that, but what are your thoughts?
Yeah, no, absolutely. We're seeing that just like 10 years ago when bandwidth was commoditized and new businesses emerged, such as Netflix and other over-the-top providers that are sending HD quality video over the internet, we think the same thing is happening now, and we're seeing it already. When cloud storage is commoditized and made readily available to everyone who wants it, we think there'll be new business models emerging. There'll be new use cases like the ones we talked about today in artificial intelligence-enabled data, and a whole range of others that we haven't even found out about yet. And we do believe that that's really going to happen. We're seeing it already.
I have to agree. Well, folks, thanks for sticking through this whole event with us, I should say. This is The New Possible, a series underwritten by Wasabi. Big thanks to Ted Dunning of MapR and Nima Negaban of Connecticut. Very, very cool companies. Check them out online. Search for these guys on LinkedIn. They have all kind of great commentary and speaking engagements and so forth. Go to Strata to see both of them present, I'm sure. Once again, thank you so much. It's an exciting new time. I'm looking forward to the next in our series in a couple of weeks. With that, we're going to bid you farewell, folks. Take care. We will archive this webcast. You can find it shortly after the show concludes, and we'll talk to you next time. Take care. Bye-bye. Okay, speakers.